Alright, welcome back. Now, what we're going to consider is the mathematical expression that is behind this backpropagation through time. Okay, so we're going to consider the mathematical expression for backpropagation through time. Okay, so previously we've gotten to understand what backpropagation through time is. Alright, so now let's see the mathematical expression as well. Okay, so this is the feed forward, right, and then this is the the backward propagation. So in the feed forward or in the forward propagation, we have our non-linear function over there, right? Which in this case we said it's going to be tan. Okay, it's going to be tan h. Okay, and then this tan h is being fed with why. Okay, it's being fed with why and the hn. Okay, in the hn. So this one multiplied by this one, and then you apply this non-linearity on it to get your output. So that's basically what is it. Okay, but this hn, okay, this hn is as a result of this, as a result of this and that. Okay, as a result of this and that. So that's basically what you see. So we have the why, which is this one, and then we are multiplying by hn, but the hn itself, okay, the hn itself is as a result of this expression. Okay, that is whh multiplied by the previous hidden state, that's hn1. Okay, so whh multiplied by the previous state, okay, so this one, okay, plus xn multiplied by whx, okay, xn multiplied by whx. Okay, so when you add these one together and then apply another non-linearity, in this case that is also tan h, okay, you apply another non-linearity over there. Okay, so that's basically the entire expression, right? That's basically the entire expression. And then that's the forward propagation. So you have your input data, you multiply by this plus, right, plus this one, the previous hidden state, multiply by another weight, and then you apply the hidden the non-linearity on it, which is this, and then now which give you the hn, okay, which is going to give you the hn, and then you multiply it with the why, okay, and then you apply the non-linearity on it, and you're going to have your yn. Okay, so that is the feed forward. Now for the backward propagation, right, what we're going to do is to find the derivative. Okay, to find the derivative of that. So let me clean up. All right, so to find the derivative of it, right, we're gonna find the derivative of that, and then the derivative of whatever is in the bracket. Okay, that is what we're finding over here. Okay, so the derivative of y with respect to hh. Okay, the derivative of y with respect to whh. So for that, what you're going to do is that you're going to find the derivative of this and also the derivative of hn. But don't forget the hn is the entire thing in the bracket, so we need to find the derivative of that. Okay, so the derivative of y is here. Okay, and then now we need to find the derivative of whatever is in the bracket. Okay, so now let's see how we do that one. So in the bracket we have we are doing the derivative with respect to wh. Okay, and don't forget this one here. Let me change this. So don't forget whatever that we have here. This is a product. Okay, it's a product of whh and then whn minus 1. Okay, that is what it is. So if you want to find the derivative, right, remember in derivative, if you find derivative of say a dot b, right, a multiplied by b, then you find the derivative of the first one. Okay, derivative of the first one, you maintain the second one, right, derivative of the first one, you maintain the second one, plus derivative of the second one, and then you maintain the first one. So this is how it works, right? First you find the derivative of the first one, you maintain the second one, you don't derive it, and then you find the derivative of the second one, and then you maintain the first one, you don't derive it. So if we pick this one and want to find the derivative of it, okay, first we maintain the second one. Okay, we maintain the second one, which is this. Okay, now since we are finding the derivative with respect to whh, that is going to be 10 to 1. Okay, so 1 multiplied by whatever was there, right, 1 multiplied by it is just going to be like that. Okay, plus now we need to maintain the whh and then find the derivative of that. So the whh is maintained, and then we find the derivative of this one. Okay, so that's why you're seeing the derivative of this one as well. Okay, now we are supposed to find the derivative of this part. Okay, but don't forget we are finding the derivative with respect to whh, and since there's no whh in this term, the entire thing here is going to be 10 to 0. okay, the entire thing is going to be 10 to 0. So that's why we don't have any plus anything else. It's because it's just plus 0, and we can ignore that. Okay, we can ignore that. So that's why we have the derivative to be something like this. Okay, so I mean, I hope you get the understanding. Otherwise, you can just, put the video back and then rewatch it, the explanation again. All right.